Plus, I tried to let it do exactly the same for my project NeckGuardian. I used advanced agentic workflows and gave the AI explicit instructions to generate the new spooler mechanism. It completely failed. The AI could handle the basic brackets, but it could not comprehend the spatial reality of the design. It failed to account for how the parts needed to interact physically in three-dimensional space. Today, I'm going to show you exactly why the AI failed and why I had to open up FreeCAD and build this entire mechanism entirely by hand from scratch. Let us look at the complexity of the spooler mechanism we are trying to build. It is not just the basic cylinder. This is a 25 mm string spooler. It requires continuous helical screw threading around the perimeter of it to guide the robotic tendon perfectly. Furthermore, it has to interface with the microservo SG90 metal gear and be accurate to physically trigger and hit the limit switches. When I instructed the AI to combine the helical sweeps with the exact tolerances needed for the servo-spline, it produced the geometry that was mathematically impossible to print and assemble. The AI lacked physical intuition. It does not understand material tension or how a micro switch clicks into place. Because the AI couldn't handle the complexity, the handmade design was the only option left that made sense. I stepped away from the agentic prompts and went back to the fundamentals of engineering in CAD. By designing it from scratch by hand, I could ensure every single parameter was exactly where it needed to be. I manually plotted helical path. I manually cut the rectangular housing for the servo. I designed the modular trigger arms to extend downwards with perfect clearance over the basic plates. Designing by hand counterintuitively had taken less time compared to the agentic prompting and getting the design out. The result is a structurally sound, flawless piece of engineering. You cannot build a physical AI reliably if you're afraid to get your hands dirty in a CAD software. Finally, the design was made. Slicing was checked was good enough, yet to be printed. Since the design was made by human, that's me, it has been taken care all the physical intricate of 3D print within the design itself. Hence, lesson is clear here for anyone building embedded AI. The Copilot AI is fantastic for software, but the physical builder still demands a master builder or a skill which can do it. Just try to know how the new spooler is printed and rest of the assembly is assembled and whether or not it works perfectly. We finally may have our prototype in place, can be trained directly by some reinforcement learning setup which will not break itself because the limits will be in place, hard limits. Further, next time we integrate this hardware with the reinforcement learning agent to see if our manual fail-safe holds up. Hit subscribe to follow the journey to see that test, and I will see you in the